This course will be explaining the ANSYS program. First of all, our course is divided into 8 sessions or 8 days. In day 1, we will be talking in general about finite element analysis, what it is, what can we use finite element to solve, and then we will be introducing ANSYS. We will be explaining what is workbench, component system, analysis system, and in general we will explain the user interface for ANSYS. Then we will be explaining the general components that we will use to solve different problems, because in order for us to solve any problem we have to first define the geometry of the problem, and second we need to divide this problem into smaller domains, which is called meshing. So we will be focusing, after explaining the user interface of ANSYS, on space claim, or the CAD software included in ANSYS that specializes in defining the geometry of the problem, which is common for different types of problems. For any problem we will do this. And in our second day we will be going deeper, or we will be explaining space claim further. We will use harder problems and learn how to draw the geometry and input the geometry for these problems. The third day we will be explaining the meshing, how to use the ANSYS mesher, and we will also be explaining the meshing at a level that is intermediate. We don't want it to be so hard, so our meshing explanation will be intermediate. You should be able to deal with any mesh or any domain and do the correct meshing which suits the problem and give you the accurate solution to this problem. In our fourth day we will start to explain different solvers. We will start by the static structure, because now we've explained the general or the common things that we use for any problem, which are the ANSYS CAD software, which is the space claim, and we've explained how to input our geometry or draw it in ANSYS, whichever you're gonna use, and we've explained the meshing, or how to divide the domain of the problem into smaller domains so that you can use finite element analysis. Now we are starting to go and explain each solver alone. So we will start by static structure. You should be able to solve problems like this and get the deflection, the stresses, the deformation, and different type of stresses and the deformation in each direction. You will be able to introduce the fixations for your problem if you have a roller, a fixed support, etc., and define the material for the problem and find the solution, which is the deformation and the stresses. On our fifth day we will be explaining the thermal solver. As you can see, this is on the right we can see the heat sink, which is used to cool computer CPUs by fans. You can see the temperature distribution as shown, and the same thing on the left. We will be using the static thermal and the time transient thermal analysis, and in the time transient thermal analysis we will have a quenching problem. We will see the rate of cooling of a metal when quenched in water. And our sixth day the sixth and seventh day we will be talking about fluid solvers, which are CFX and Fluent. On day 6 we will be talking about CFX because it has less options than Fluent. It's more simpler, so we will be explaining the CFX first, and then we will explain the Fluent solver, and we will compare between them. On the 8th day and part of the 7th day we will be explaining how to post-process our problem, our solution, our results, which is post-processing is displaying your results in a neat way so that everyone can understand it. You will learn how to make a report of your solution. You will learn how to make different planes in different parts of your domain, draw charts, diagrams that you need, and how to export your results in a neat and clean way. You will also learn how to define new variables in the post-processing, and we will explain the post-processing for ANSYS in detail. And last but not least we have day 9, which is an extra day. It will be in one of the 3 subjects, either dynamic mesh FSI, which stands for Flow Structure Interaction, or User Defined Functions. Which one will we choose? We will choose based upon your requests. The most requested, we will make this lecture for this topic. The dynamic mesh is basically a moving mesh. When you have a moving object, let's say a rotating cylinder or a propeller, you can model the movement of the propeller or the rotating cylinder with one of 2 options. The first option is moving or rotating the wall, which is the cylinder or the propeller, and the second option is rotating the mesh around the cylinder or the propeller. So Either you rotate the propeller or the mesh around it. Either way, it's the same thing. Both will give the same results. So that's dynamic mesh, but we will explain it with more examples and more detail. Our second option is the fluid structure interaction, which is basically a system coupling, which is a coupling. A system coupling is a coupling between two solvers or more in the ANSYS program, because you know ANSYS software has many solvers included in it. So when you transfer a solution from one of the solvers to the other, that's a coupling. We say we have a coupling here. Like as you see those two images down there, you have on the bottom left you have an image of a plate that is standing, and the fluid is passing by this from the right to the left. The fluid flows from your right to your left, and due to the force and drag on this plate, it deforms. So we have the image on the bottom right. This is the plate, but we have a deformation or a movement, the deformation in the plate because of the drag force on it due to the fluid flow. So this here we have a two-way coupling, which means we have the fluid solver, which solves the flow in our domain around this plate, and we have another system which is structure, ANSYS mechanical, or the structure solver, which takes the stresses and the forces from the fluid solver and sends it to we send it to the structure solver, and the structure solver takes these stresses and sees what deformation they cause. So, and then we send the new geometry after the deformation to the fluid solver, and this process keeps repeating itself until we have the final deformation and the final shape of the flow. This is the flow structure interaction, and it is very important for aerospace applications, because starting from the design of fans and propellers, it is very important in the verification of the design of pre-twist. If we have a pre-twist in the wing, say we have a wing for a specific or certain airplane, due to the moment coefficient or the moment on the wing, we sometimes do a pre-twist, twist the wing or the propeller in the direction that is opposite to the direction that it will twist to under flow. So let's say we have a wing, when the aircraft is flying at full speed, there will be a deformation of 3 degrees. So what we do is we do a pre-twist of -3 degrees. This way, when we are at full flight speed, the total deformation will be 0, because we have a pre-twist of -3 and a twist of 3 degrees due to the moment. We don't have to add weight to make the wing too rigid. We can accept it. It can be flexible, and we will accept the deformation, but we have to know that in the design we have a pre-twist. So the finite element analysis is a good way because it has accurate solution. It is excellent in dealing with these types of situations and these problems. Our third option for the 9th lecture or the 9th day is the user-defined function. A user-defined function is basically a function that is not included in the ANSYS software, that you define it yourself. One of these, you can define a function or write a function using C programming language, and use this function as the fluid flow or a harmonic vibration or a non-uniform vibration, a random vibration, or whatever. Anything, you can write a function for it. We will learn how to write these functions and how to use them and import them. You can have functions for the mesh. In the dynamic mesh, you can use a user-defined function to identify and define the movement of the mesh. You can also have a user-defined function for a deformation or a certain mode of vibration, and import it to ANSYS to have the nodal analysis for it. So depending upon your requests, we will make the 9th lecture into the most requested topic. This here is a video in which we have a morphing wing. In this wing, the structure solver was used to stress the flap. A morphing wing is basically a wing, but instead of the flap, we use smart materials to deflect the flap. So instead of using regular hydraulics, we use smart materials to deflect the flap, which was done by the structure solver, and then we couple the structure and the fluid solver together. So this is a one-way coupling. We're taking the deformation from the structure and importing it to the fluid solver. This is a time transient analysis because our deformation and flow changes with the time. We could have done it using UDF or user-defined function. We could have written the user-defined function for the deformation of the airfoil.